let's start off with a few definitions. The first is just what isomers are, and we've talked about this before. Isomers are different molecules, but they have the same molecular formula. But there are some subclasses of isomers. The first are constitutional isomers, and this just means the atoms are connected differently. So let's look at an example of constitutional isomers. Okay, so here's a 6-membered ring with a 2-carbon chain coming off of it. If you count up the carbons and hydrogens, it's C8H16. But we can draw a different molecule. We still have a 6-membered ring, but now I have the 2 carbons here and here. But this one is also C8H16. But of course, the connectivity is different. I've essentially taken this carbon group, broken it from here, and attached it to here. So these two represent constitutional isomers. Now our second definition is stereoisomers. Stereoisomers have the same connectivity of atoms, but different spatial or 3D arrangements. One case where you have stereoisomers is with double bonds. Remember, double bonds lock these groups into place, so there's no free rotation. In both cases, you have a 4-carbon chain. So the connectivity is the same, but 3-dimensionally, these are different. In this first one, you have these 2 methyl groups on opposite sides. On the second one, you have the 2 methyl groups on the same side. So these have different 3D arrangements. These are stereoisomers. All right, and let's actually look at this dimethyl cyclohexane here and give it some 3-dimensionality. One option is to have both of these methyl groups pointed out towards us. Another option, let's have one out and one back. The connectivity is the same. It's still, or they're both 1,2-dimethyl cyclohexane. But they are in fact different molecules because of their 3D structure. Essentially, this carbon here, the group, has been inverted. Since the 3D is different, these are stereoisomers.